Hello Internet, this is your daily dose of data science. Today we are going to complete the cleaning of Airbnb data. In the previous video we started cleaning this data. If you had not looked at the video, I suggest that you go back and look at the video. The link to the video is in the description, and also it will show up in above this video in one of the cards. So I would suggest that you go and look at it, but if you prefer continuing with this video and seeing how I'm going to complete cleaning this data, then it is just fine. Hopefully this video will be so independent from the other video as much as possible. So last time we imported the data, Airbnb data, and we determined that we didn't need license because it had a lot of missing values. So if I run this and this and this function here, we had put it in libs, and it is the function that is helping us to print stuff from the data frame, some properties of the data frame that will help us in analysis. And one of the properties that we're printing is shape, columns, data types, and so forth. And when we printed this, we discovered that we don't need this because it has a lot of missing values. Yep, and also this function was imported into this notebook from here using this this command. Then what did we do next? We looked at house rows and cleaned the house rows. Previously, in the previous video, we created this column, but after I recorded that video, I came and looked at what we did, and I found out that we don't need house rows, and we don't need this clean house rows. So I'm going to delete also clean house rows, but we will need the missing house rows, which is a boolean, which tells us if house rows is missing or not. More about this in the previous video. Then we looked at last review. Then we worked with the missing values, and we also worked with the duplicate. So we are going to continue from here. Let me just call this video 2 markdown. Run this. So hopefully today I'm going to complete the whole of this cleaning of this file. But you know, cleaning never ends. There could be some stuff that may leave behind, which you can continue cleaning at your own pace, but at least I would have hit major aspects of data cleaning using this file. And in this video, the code will be found in Colab, and the link to the code is in the description. Also, the data is found in Kaggle, and the link to the data is also in the description. So you can decide to code along, or you can watch and then you code later, or you can watch and then you get the code and the data and you run and you see how things interact with each other. So let me run everything that I did in the previous video, then we can continue from here. Yep. So far we don't have any missing values and we don't have any duplicates, so we can start looking at column by column. So let me look at data, and I see which column to begin with. Yeah, so we have ID. Hopefully ID is unique. We can do data dot, so you can access data.id like this, but I prefer accessing the ID like this, because this one here, based on someone who is looking at your code, explicitly defines the ID as a column, rather than doing .id like this, because someone may not know whether ID here is a function of the data frame or it is a column. So if it is a column and you're working in a team, I would prefer you put like this, because this someone will know that is a function. So .unique, I mean this is a column and then this is a function. So this will give us the array, but we want to know the shape. So this has 83,000 of unique values in ID, and when we do data.shape, it also has 83,076. So this shows that the ID column is unique. And now we can look at the name column. Okay, name. So let's do data name. What do we need from name? So with the name, remember we have this function here that helps us work with natural language processing or texts. So we are going to use this function to clean this data. We'll have this. I also want this W to be replaced with which I included it here in the deconstructions. The definition, or the way we defined these deconstructions and created these two functions, there is also a video which is part of this card you can look at. Yeah, but it's just more of just pre-processing a text. So we are going to use this pre-process to pre-process this data name, and we don't want to remove stopwords, so we're going to say remove stopwords is false, and we run this. So when you run this, you find that this is looking more clean as a name. So we are going to put this in a new column. We're going to call it clean name. But when we look at this, I would call it clean name, but I feel like it should not be clean name, because this looks like bio, large room with private entrance, amazing West Village. So it is not a name of something. Let's call it clean accommodation bio, and it should be this. And after doing that, we no longer need this column, so it's better we remove it. Yep, and I think that is for the name. Let's look at another column. Let me just look at data. So let's look at host ID. Host ID, what I need to know about host ID is if it is also unique. So I'm going to do the same stuff that I did here. So let's make this for you who will look at this file, host ID. You'll know what I'm doing here. Markdown, run that, then we're going to do this, then host ID. We want to know if it is all unique. So it is also 83,076. It is unique. So I feel like we have two IDs and we could only use one. We could decide we either use ID or host ID. So let's delete one so that our data is lighter. Delete data host ID. It's not useful. We can use ID. What else do we have? Data. We have host identity. So let me copy this and let's say here 1 2 3. We are working on host identity. So what do we need from the host identity? This data, when we look at it here, the host identity is either verified. Let's look at the unique values. Is either verified or unconfirmed. But when you look at the name, it is host identity verified. So we could make this a Boolean column where we say host identity verified true is if you're verified, and then false is if you are unverified. We created a function here, and this function here is called host identity verified. It takes in a string, which is text, and it returns a Boolean, and it returns true if text is verified, and then false if the text is not verified. So we're going to use this function on this column to determine to make the column Boolean. So dot apply and then we're going to apply this function. Then when we run this, it gives us true, false, true, false. So host identity verified, we're going to say it is equal to, this is the time when I collapse that for us to see everything. It will be equal to that. Then we are going to look at our data again, and for now I want to see also the columns that are hidden here. So I'm going to write something somewhere here before video 2. I'm going to say from IPython, I want to see all columns. So I want the display max columns to be none. So from IPython dot display import display, then pandas dot options dot display dot max columns should be equal to none. This will help me display all the columns in my data frame. My data frame does not have a lot of columns, so it should be able to easily display all the columns. So the column that we have just adjusted now, it is host identity verified, and it is here. This is host identity verified. I don't know if we were going to need host name, so we're going to remove host name because it is not useful in any analysis, because we already have host ID, and also it's good to not to have names in any analysis so as to enable privacy and protection of whoever is protection of the person whose data that you're using. For example, phone numbers and emails and names should not appear anywhere in your analysis for privacy matters. So delete that, and then let's look at the data again. What else do we need? Let's work with the neighborhood group. So I'm going to put here 1, 2, 3 neighborhood group, markdown, and I'm going to look at the unique values of neighborhood group just to ensure that they're fine. Unique. So here we have Manhattan, Brooklyn, Queens, Bronx. I can't pronounce this, and then Brooklyn. So Brooklyn is repeated. We need to rename this so that this one becomes this, and renaming this, we're going to do we're going to do data dot lock. So we want to write a condition and then lock it to a certain column, and the condition we're going to write here is data neighborhood group, which is the same column, equals to, so we want where that column equals to Brooklyn, this Brooklyn here, and the data that we are going to change is the same neighborhood group, and this should be equal to this Brooklyn. So what we are doing here is we are filtering the rows of this data where the neighborhood group is Brooklyn, and we are picking that column. So that column where the neighborhood group is Brooklyn, we are assigning values in that column to be Brooklyn. So we run this, and I think that is what we're going to do about neighborhood group. We have removed the other one when we run this, and that is what we're going to do about neighborhood. Next, let's look at data again, and this time around we have looked at this neighborhood. Let's look at neighborhood, and still pick unique values. There are so many unique values for neighborhood, so I think we should just do away with neighborhood. It may not give us a good analysis according to Airbnb. So I'm going to change this from neighborhood group to neighborhood, so that this section here becomes analysis only dealing with neighborhood. Then I'm going to run all cells, no, cancel, run all cells. So next, let me look at the data. So we have seen ID, host identity, neighborhood group, longitude and the latitude. We shall look at them at the numeric columns when we are looking at numeric columns. So let's look at country. So I'm going to again get the unique values of country, just to see if we have country in good format. Unique. So we have only one country. This is not useful for any analysis, so I'm going to put here 1, 2, 3 country, and it's a markdown. I'm going to delete country, and I'm going to delete country code because it is the same data, so we don't need this in any analysis. So delete this from the data, and we are going to delete country code. So let's run all these cells, and then we look at the data. So now we have ID, neighborhood, longitude, latitude, instant bookable. If we look at the types that we were printing here, where are the types? They are up. Instant bookable is an object. It's supposed to be a boolean. So let's convert instant bookable to a boolean, but first let's check if it is only having Boolean values. So we're going to do data, still with my unique. This video I may name it as unique usage intensive unique. Yeah, it is true or false. So we are going to make this as type. We are just changing the type of this to Boolean, and we're going to do this. Then for the people who are going to use the notebook, we tell them what this section is about, and it's a markdown. So we run this. I'm going to print the data now, and I see our statistics. So we're going to print these details down there. So when we print this, where is it? Instant bookable is a Boolean. We also have missing houses is a Boolean which created yesterday. Price is an object. Service fee is an object which should be numeric values, either float or integer. I think that is what we should look at now. Yep, so let's look at the prices. So I'm going to name this part here prices, price and fees, markdown. Run this, and I'm going to write a loop for, because so what I'm going to do is, let me just give you context. You see data here, and then when we look at the prices here, the price has a dollar symbol, and then service fee has a dollar symbol. I want to remove this dollar symbol because it is the one that is making the price an object type, and I want to make these two columns integer, no, float columns. So I'm going to do for both together at the same time. So for column in this list, and the list should contain the price, and it should also contain service fee. So for each of these column, data column should be equal to data the same column dot apply. Then this is it will pick for each value in that column. So dot apply, we're going to use a lambda function here, and we call value. So for each of those value, we are going to convert the value into a string. Then we're going to replace the dollar symbol, that's a percentage, the dollar symbol, with nothing. We're also going to replace a comma with nothing. So this is what is going to be returned, and since this is going to be returned is a string but a numeric value as a string, we are going to change this type to float so that we return a float. So let's run this. We are having an error. Name values is not defined. Let's check for value. This should be value, not values. Yep. So let's run this print again. Now we can see the service fee is float, and the price is float. And when we look at the head of the data, we can try to look at the service fee. Price is a float, and then the service fee is a float. Construction of the year here looks like a float. Let's convert it into an integer or a string without this decimal. It's weird. So we're going to have the construction of the construction year, 1, 2, 3, markdown data. This should be equal to data dot apply, and then each value should be integer. So when you run this again, we are going to see construction year does not have the decimals. Next, let me look at what else we have not done. Yeah, cancellation policy and room type. Let's start with cancellation policy and see if there is something wrong with it. Remember, this is data cleaning. You have to look at, pay enough attention into your data to make sure that everything is fine. I usually like beginning with the unique and just looking at the values that are inside there. This seems to be fine. It has only 3 categories. Then let's look at room type. So here 1, 2, 3. So data, room type dot unique, just to look at the values individually. First of all, this slash here may cause problems in some databases. Some database may think that this is a path to a directory, may consider this as a directory. So we're going to remove that slash. Apart from that, I think everything is fine. So we're going to do, this should be equal to this dot apply, and apply lambda and value, and we're going to have make that value a string the same way we did there. Then dot replace, and we are going to replace that slash with nothing, or with a space. Let me replace it with a space, and let's look at the data. Let's run this and then look at the data and see what else haven't we touched. Room type we have touched, construction here we have touched, calculated. The rest of this numerical fields we have not touched. So what's remaining is the numerical fields. So now I'm going to fetch all the columns, and then I auto fetch all the columns that are numerical. Then I'll plot charts for them, because charts will help us see how the data is distributed and identify outliers or any other weird values in the data. So column names will be equal to a list of data dot columns. So this will give me all the column names. Then I'm going to pick only numerical columns. I think this is not the best way of picking the numerical columns, but anyway, we shall see how to use this later. Let me just say numerical columns will be equal to how will I pick data dot select. I want to select data types, and the data types I'm going to select will be integer, and so int 64 and float, because those are the numerical columns. Float 64. Then I am going to get the columns, and this is going to return for me the array of the columns that have these data types. Then I'm going to make it a list. And that will give me a list of numerical columns. I want to plot the numerical columns on histograms, so I'm going to have for columns, for a column in numerical columns, we are going to do cbon dot hist plot. I hope I can remember this. Data equals to data, and then the x value equals to column, and then we're going to do plt dot show. So when I run this, voila, we have our charts. So let's look at this. This is for ID, not necessary, and then this is for latitude. We have this value here, which I doubt if it is an extreme value. Then we have the longitudes. So I hope this is like inside the map, because they are bordering each other. There are no values that are very far from the latitudes and the longitudes, and it is within, I think, 1 degree, 74.2 to 73.72 degrees. Also here 40.5 to 40.9, 1 degree. Then the years, this is 2002 to 2022, this year. The price, you can see the distribution is what we can expect, but the minimum nights is a lot. First of all, we have a 0, which is very far. That means that there is a negative value for minimum nights, which is not expected. Then there are also very big values. That's why this chart is looking empty. So we're going to work with the minimum nights. This other one, this is a skewed graph, which is understandable. Even if we have an extreme value here, you can see that it goes, the distribution follows that kind of shape, the same as this. So we don't mind so much about extreme values for this kind of shape. Yeah, so let's start with the minimum nights. I'm going to have here data minimum nights, and then dot max. Max is a function. Let's also look at the minimum is a negative, and then let's look at the mode. Mode is 2. Okay, so we can see that this value is too big, but also we have negatives. So let's first do away with the negatives. So we want data to be data where the minimum nights is greater than 0. Then let's run this again. And let's look for minimum nights. I think this will take some time when it's running. Still running. Yeah, so here we can see that the minimum nights are now beginning from 0. Now let's work with the minimum nights for a year, that is 365 days. So let's change this. We're going to have two conditions here. Should be greater than 0 and it should be less than a year, that is 365 days. Should be less than 365. Let's work with this. I'm going to move this code here before the plots. Here, then it should be before the plots. Here. Then when I run all cells, we're going to have at least minimum nights should show something. Yeah, we are seeing something here. They are kind of weirdly distributed. 2 has a very high value. There are so many people who have minimum nights as 2, but the rest are weirdly distributed. Yep. Yeah, so let's look at the data again and we see what we have not worked with. The rest of the numerical columns I think are just fine, but you can continue cleaning in case you see that there is something that needs to be done for that column. Most of the numeric columns, we have not touched them a lot. So now what's remaining is just to have consistent column naming, and we are going to I'm going to now have, I don't know why I deleted them, but I'm going to have column names will be equal to the list of data dot columns. Then we are going to define a function that will help us to pass these column names. We can see this is separated by underscore, this is separated by a space. They are not consistent. This one starts with an uppercase, this one starts with a lowercase. So we want to create a function that will pass these column names. So we call it pass column names. And we are going to pass the column names here. So column names, and this is a list. I don't know what I'm going to be returning now. Let me just leave it there. So renames will be a list. Then we're going to do a loop for column in call names. We are going to say if the length of the column dot split, if we split it by space, is greater than 1, then the parts of the column name should be column dot split. Then the renames column will be equal to, we're going to join it with an underscore dot join, and then we're going to join parts. Then we're going to make it lower. Then we're going to, after that, we're going to return renames. So this will return a list also. So we're going to return here a list, and it will be a list of these names, but they will all be consistently separated by underscores, and they will be lower. So what we're going to do now is to do the pass. So new column names will be equal to this. Then column names. I think it will be wise for us to move this to our libraries. Then we save this. Then we move this to the previous column just to refactor things, and then we run everything. So this will be the new column names, and then we are going now to have to rename the columns. So we're going to say data dot rename, and we're going to rename columns should be equal to new, something went wrong, new column names. What did I do wrong? Says that renames list indices must be integer, not string. Okay, so where did we go wrong? So we have renames here. This should be column names. I think this should be an integer. Yeah, but let's do this. Instead of that, let's make this one a dictionary. Save it. I don't want that to be an integer. Run all cells. Let's wait and we see if that's going to solve that issue. Then here in place, yep, it has solved it. So in place equals to true. Voila, let's look at the data again. And now we have the columns. The titles of the columns are now all consistent. So I think to this point the data is ready for further analysis. I'm going to stop cleaning this data here, and next time I think we can use this data to do analysis. So I'm going to save it to CSV, and my data is in a data folder in this folder here, and I'm going to call it clean airbnb airbnb.csv, and then I don't want to save it with index, so index equals to false, and run that. So this will save my data here, and when we look at this data is basically more clean than the way it was before. So we can look at the shape of the data when we finish. Shape, we completed cleaning with 20 columns and 83,000 records, and we began cleaning with 102,000 records and 26 columns. So the quantity of data does not determine the kind of analysis you may do, because we find lots of the data that you have is just garbage. But for this case, lots of the data was not garbage. We have remained with close to 3/4 of the data, which now we can do analysis with. So hopefully tomorrow we can do analysis. I was thinking of using Google Data Studio, but until tomorrow we'll never know. Yeah, so teach someone, learn something, teach someone. Bye.